Hi, I'm Tolentino. I worked on the write-up and making the website, as well as doing some research into community core vision.
Hi, I'm Tien. I set up the environments and I did some MT4J research and a little bit of coding.
Hi, I'm Melody. I did some MT4J research and I also coded the app.
I'm Sam, and I set up the Multitouch device, and I also integrated that with Community Core Vision. This is the box we used for our setup. This is the input device. We use the touch interface on top. We had an external light source up here to provide better lighting. You can take this off. This is just a piece of paper on top of the photo frame. On the inside, we have the webcam centered and taped to the bottom to record the shadows from the top.
So this is community core vision. When Sam puts his hand on the box, you can see here that community core vision registers the input from his hand. What it does is it reads the shadows and then uses that to create blobs and coordinates, which are sent to our program to determine the kinds of gestures that the person is doing when they touch the box.
So this is our bubble popping game. You get 10 points for popping a bubble. There's a 15-second timer. And there's eddy bubbles generated at the beginning of the game. When the timer runs out, a little pop-up comes up telling you your score.
Okay, so here's our code. We created a new file that launches one of the MT4J examples. The example that we chose to manipulate was the physics scene example. If you know the physics scene example, it's the example where a user can drag different shapes across the screen. Here we launched the physics scene example so that we can show our bubble popping game. So in the physics scene file, we manipulated it by creating two new variables. We create the timer and score variable. Here we initialize the variables. The score is initialized to 0 and the timer is initialized to 15 seconds. After that, we create a text area to display the score on the scene. And to do this, we create a font for this score, and then we set the position for the text area so that the application knows where to put the score. And then after that, we call these two methods here, set no stroke and remove all gesture event listeners, to prevent the text area from interfering with any user gestures. After that, we create a timer text area, and we use the same code as we did above here in order to create this text area. After that, we create an action listener, and in this action listener, what it does is it every second it listens, it checks to see if the timer is greater than 0, and if the timer is still greater than 0, it decrements the timer and then updates the timer text area so that the user knows how much time that they have left for the game. If the timer runs out, the code here, it removes all the elements on the scene so that it clears the canvas. And then after that, it creates a text area to display the end of the game message. And then it also displays the final score that the user got. And here we just start the timer. And this code here, this is where we generate our bubbles at the start of the game. 80 bubbles are populated for the user to pop. You can see here that the physics circle is what we are using to represent our bubbles. The most important part here is the gesture listener. It listens for the user input, and if the gesture is a tap, then it destroys the bubble here. And then after that, it updates the score and increases it by 10. And then after that, it updates the score text area so that the user knows that they were awarded 10 points for popping a bubble. And that's pretty much all the manipulations that we made to this physics scene file.